Hi, this is Nimla Rednam. In this video, I am going to discuss exercise 5.3, which is about finding the square root using either repeated subtraction or prime factorization that we have discussed in the previous video. Now here in this exercise, they have given a lot of numericals. What I am going to do is, I will be solving one sum per question that they have given, and I want to give the rest of the solutions as a time-lapse video because there's no explanation as such, because it's the same method that we'll be using throughout. So I'll try to upload a time-lapse video of all the solutions in the coming videos. But for now, let's take one sum per question that they have given and try to discuss it and solve it. Okay. Let's look at the first question here. What could be the possible ones digit of the square root of each of the following numbers? Now here we have discussed about the ones digit. If you remember, we have seen that the squares tend to end with only few digits in the ones place, right? So if you remember, 1 and 9, the squares of the numbers ending with 1 and 9 end with 1. The squares of the numbers ending with 2 and 8 end with 4. The squares of the numbers ending with 3 and 7 end with 9. And the squares of the numbers ending with 4 and 6 end with 6. The squares of the numbers ending with 5 end with 5. And squares of the numbers ending with 0 end with 2 zeros. Right? So, this is what we have already discussed. Now they're saying what is the ones digit of the square root. So the number given is a perfect square, and what could be the possible ones digit in the square root. So here clearly, because this is 1, I know that the answer is 1 or 9. Here it is 6, so the answer is 4 or 6. Here it is 1 again, so 1 or 9, and here it is 5, so the answer is 5. Right? So this is about the first question. Next, without doing any calculation, find the numbers which are surely not square roots. Now here also we have seen that whenever a number ends with 2, 3, 7 and 8, these 4 digits, the perfect square, any perfect square will never end with these digits. So if you have a number that ends with one of these digits, then you can conclude that it is definitely not a perfect square. So this is definitely not a perfect square, it's ending with 3. Here it's ending with 7, so this is also not a perfect square. Ending with 8, so not a perfect square. Now here this one is ending with 1, so may or may not be a perfect square. We can't conclude just by looking at the ones digit or without doing any calculation. Okay, so that is about the second sum. Next, third sum. Find the square roots of 100 and 169 using repeated subtraction. Now here we have already done repeated subtraction earlier also. What we are going to do is, we will start with the first odd number and we'll start subtracting consecutively with the odd numbers. Okay, so here I have 99. Okay, and 99 minus 3 will give me 96. 96 minus 5 will give me 91. 91 minus 7 will give me 84. 84 minus 9 will give me 75. 75 minus 11 is going to give me 64, right? 64 minus 13 is going to give me 51. 51 minus 15 is going to give me 6 here and 36. 36 minus 17 is going to give me 19, and finally 19 minus 19 will give me 0, right? So here I have the repeated subtraction, and I'm going to count the number of times I have subtracted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means that square root of 100 is 10. If you remember, we have looked at the reason for this also. It's that the observation that was made is that the sum of first n odd natural numbers is n square, And from there we seen that, repeated subtraction can be used to check if it is a perfect square or not. If it ends with 0 after a few subtractions, then you can conclude that it is a perfect square. And further, number of subtractions you have done is nothing but the number of odd numbers you have added. So that will give you the square root. Okay, so that is one method of finding the square root of a given number. Next, I have find the square roots of the following by prime factorization. I will do the first sum, 729. Okay, so let's take 729. Fourth question. Here we are using prime factorization, right? So please make sure that you don't use any factor. You need the prime factors. Usually in a hurry in the exam you might use any factor. You just need to divide. It's not normal division. You want only the prime factors, so you will be dividing only by prime numbers, because otherwise you will get a wrong answer for your square root. Okay, so here 2 is 729 is not divisible by 2, or 2 is not a factor. Next 3, if you look at sum of the digits, it's 18, so 3 is definitely a factor. 3 2s, 3 4s, 3 3s. Again, I'm going to take 3, 3 8s are 3 1s are, 3 2s are 3 7s, 3 9s, and then 3 3s, right? So this is my prime factorization. So I'm going to write 729 as 3 into 3 into 3 into 3 into 3 into 3. I have 6 3's here. Okay. So now I have to find the square root, right? They're asking us to find the square root, right? I'm going to pair it up. So what do I have? I have 3 cube, which is 27. So 27 is the square root of 729. That is how you will be solving the sums in fourth question. Please solve the rest of the sums. And next, let's look at the fifth question. For each of the following, find the smallest whole number by which the given number should be multiplied to make it a perfect square. Now, in these kinds of questions also, first step is prime factorization. Then you will see that there are one or more unpaired prime factors. Then you will try to pair them up and make it a perfect square, right? So the first step is again going to be prime factorization, 252. So here I have 252, okay, 2 6, 2 3's, and then I have 3 2's, 1's, 3 7's, right? So 7 is a prime number, so I have to stop. Now 252 prime factorization is nothing but 2 into 2 into 3 into 3 into 7, correct? Now what should this number be multiplied by in order to get a perfect square? Clearly the answer is 7. Okay, it should be multiplied by 7 in order to get a perfect square. Okay, so what is that number? 7 2's 14, 36, and 1764. Okay, that is the number I get when I multiply the given number by 7, and it happens to be a perfect square. Now they're asking us to find the square root. I already have the prime factorization, so this is easy, right? This is one pair, this is one, this is one. So I have 7 into 3 into, sorry, 2 into 3 into 7, which is nothing but 7 6 42. So 42 is the square root of 1764. Okay, so that is how you are going to be solving the questions in fifth sums in fifth question. Next, sixth question. What they're asking is same question, but now they wanted to divide the given number by the smallest whole number such that you get a perfect square. Okay, again you have to look at the unpaired prime factors. So here the first question is again 252. So my prime factorization is done for me. Okay, so I'm going to directly write 252 is equal to 2 into 2 into 3 into 3 into 7, right? This we have already done in the previous sum. Now, what is the unpaired prime factor here 7. So it should be divided by 7 in order to get a perfect square. Now when I divide by 7, what do I have? 7, 3, 7, 6, right? So 36 is the number, and what is the square root of 36? 6. So the answer here is 6. Okay. That is how you will be solving the 6th question. Next, coming to the 7th question. The students of class 8 of a school donated 2,401 rupees in all for Prime Minister's National Relief Fund. Each student donated as many rupees as the number of students in the class. Find the number of students in the class. Now here, if the number of students in the class is n, then how much did each student contribute? N rupees. That is what they're saying, right? Each student donated as many rupees as there are students, right? So that is n rupees is the amount contributed by each student. Now, if in that case, what is the total amount? Total amount is going to be n into n, which is n square. This is given to be equal to 2401. If the total amount is 2401, then what is the number of students, which is nothing but they're asking you n, that means they're asking you the square root of 2401, right? So here, I'm going to do it here itself. I'm going to use prime factorization, okay? So 2401, clearly 2 is not a factor, okay? 3 is also not a factor. Let's check 7. 7 3s 21, and then I have 30, 7 4s 28, and 21 7. So 7 is going to be a factor. 7 3s, 7 4s, and then 7 3s. Again, I'm going to have 7. 7 4s 28, 7 9s. And this is 7 into 7. So you can see that I have 2401 is equal to 7 into 7 into 7 into 7. So now I'm interested in square root, because n is nothing but square root of this, right? Which is nothing but, if I pair them up, I'll get 7 into 7, which is 49. So how many students do we have in the class? We have 49 students in the class, and each student is contributing 49 rupees. Okay, so that is your 7th sum. Sorry. So next, let's move on to the 8th sum. 2025 plants are to be planted in a garden in such a way that each row contains as many plants as number of rows. Again, the same thing. Here what we are going to do is, if I take the number of rows as n, then how many plants are there in each row? In each row, the number of plants is going to be n again. And so I have n square is equal to 2025. So in order to find the number of rows or the number of plants in each row, I need the number n, which is nothing but square root of 2025. I'm going to do the prime factorization here. Clearly 5 is a factor. I'll take that first. 5 4s, 0s, 5s. Don't forget this 0 here. And again 5, 5 8s, 5 1s. Now here I have 3 is going to be a factor. Don't be tempted to take 9. In this case, you might not end up in a wrong conclusion, but you should always take the prime factors. So 3 2s and 7s, 3 9s, and then 3. Prime factorization means you need the prime factors for the division. Okay. So here you can see that 2025 can be written as 3 into 3 into 3 into 3 into 5 into 5. So I'm interested in square root of this. So I'm going to pair them up. I have 2 3s and 1 5, which will give me 45. So this is the number of plants in each row and the number of rows. Okay. So this is the answer for your 8th question. Next I have 9th question. Find the smallest square number that is divisible by each of this 4, 9, 10. 10th is also the same question. Smallest square number that is divisible by. We have seen in the solved example in the previous video, we have seen that what they are asking you is a number which is divisible by all the 3 numbers that they have given, and they want it to be a perfect square. So what we're going to do is, first of all, what do you mean by a number which is divisible by the given numbers? It is a multiple, and it is a smallest number, so, and it is a common multiple, and so you're talking about least common multiple here, right? But we are not stopping there. We want it to be a perfect square. So first of all, you'll find the LCM, and then we'll make it a perfect square. We already done that using prime factorization, making the given number a perfect square by multiplying with the least possible number, right? So let's take up 4, 9, 10. So here I have 4, ninth question. This is the ninth question. 4, 9, 10. First of all, I'm going to find the LCM. Okay. I need to find the LCM. LCM of this is, take 2, right? And next I will take 3. Okay. 3 one more time. And then 5. This is how you find the LCM, right? So I have the LCM equal to 2 into 2 into 3 into 3 into 5. Okay. So this is nothing but 9 fours 36, 36 into 5. So I have 180. 36 into 5, which is nothing but 180, right? Now I want to make this a perfect square. How do you do that? You pair up and see which is the unpaired prime factor. It is 5. Okay. So what we are going to do is, I am going to multiply this number by 5, which will give me 900. Okay. So 900 is the smallest square number that is divisible by 4, 9 and 10. Okay. The next sum is also exactly similar, same as this, 8, 15 and 20. Let us see that. 8, 15 and 20. Okay. 10th question. 8, 15, 20. I'm going to start with 2, 2 fours, 2 tens, again 2, 2 twos, 2 fives, again 2. Next I'll take 3, 3 fives. Next I'll take 5. Right? So my LCM is equal to 2 into 2 into 2 into 3 into 5. Now here you can see that, and what is this number? This is 8 into 3 5 is 15. So which is nothing but 8 into 15 is 120, right? Now here you can see that I can pair only this. The remaining 3 prime factors are unpaired. In order to make it a perfect square, I have to multiply by each of these. Okay, so I have to multiply 120 by 1, 2, 1, 3 and 1, 5, so that I pair up all the prime factors. Now how much is this? This is 30, so this will give me 3600. Okay, so 3600 is the smallest whole number that is divisible by each of the numbers 8, 15 and 20. So this is about exercise 5.3, and in the next video we will be looking at another more robust and standard method of finding the square root, which is the division method. Now here the repeated subtraction and the prime factorization, these are useful for such kind of questions like the 9th and 10th question that we had, and smaller numbers. But if you have 4-digit number or a bigger number, or if you have a number which is not a perfect square, still you will be able to find the square root of it using the division method. Okay, so that is more reliable and more standard method to find the square root. We'll be looking at it in the next video.